So here is one of your problems from my math lab, and one that it's dealing with an application of an exponential. We know it's an exponential because we have a base of 4 raised to a power with an x in it. So that's how we know it is. Now this happens to be a lowercase t because we're talking about hours, so that's for time. And the capital T is in temperature. So to find the temperature after 2 hours and after 3.5 hours, we basically are just going to be putting in a little t in for that. So let me write down A. For t is 2 hours. We are plugging this in. 200 times 4 raised to the negative 0.1 times 2 plus 29. Be sure to practice this on your calculator because sometimes it can get tricky typing in an exponential. What I have, and I've double checked it, is this is 180 and it goes 5, 7, dot, dot, dot. But my math lab is actually going to ask for the tenths place. So this is approximately 180.6. So just so you know, that's going to be your answer in degrees Celsius. When we plug in the 3.5, you can do second enter on your calculator and it'll pull up this equation that you just typed in. But the 3.5 is going in where the 2 is. You'll find that this is 152.1144, keeps going. So this is approximately 152.1 degrees Celsius. For part B, we're looking to see how long the cooling has been taking place if the block has a temperature of 129 degrees Celsius. This is the capital T as 129 degrees. So I put it here. We are trying to get this 4 raised to the negative 0.1 raised times t, 4 raised to the negative 0.1 t by itself. We have to do the order of operations. Namely, we have to subtract by 29 first. So I'll have 100 is 200 times 4 raised to the negative 0.1 t. I take a look at my equation. I have 4 raised to the negative 0.1 t that I need by itself. So that means I'm dividing by 200. So I have 1/2 is equal to 4 to the negative 0.1 t. Now, these are not exactly the same as far as bases go, so what I need to do is a little bit of algebra using the exponent rules that we've seen again and again. I can rewrite 1/2 as 2 to the negative 1. That's as simplified as I can get. So how about I try and rewrite 4 raised to the negative 0.1 t as something with base 2, a base 2 raised to some power. The process looks like this. We know that 4 can be written as this, and we have this rule with exponents that if you have a to the m raised to the n, then you multiply those two numbers. So I'm going to do that here. This will now be 2, and this is negative 0.1 times 2, which would be negative 0.2 t. So if I take this up here, I know that 2 to the negative 1 is equal to 2 to the negative 0.2t. So once I have the same base like this, I can set my exponents equal, just ignore the 2 on the base. So this is negative 1 is negative 0.2t. Finally, it looks normal where I can just divide, and I'll find out that t is 5. So not so bad. That's how many hours it's been sitting to get that. Now for part C, as t goes to infinity, what we want to do is we want to remember that as if t is going to infinity, this is a big number. If it's a big number, then you can actually work with your table just to check it out. Like you could go to table set on your calculator, and you can just start it at something large. So at the start, just put in 1,000. What you'll see is all the y values are, these are the capital T values, are all 29. So that just kind of leads you to believe what the answer is going to be. But if we go back to what the original function is, this is 200 times 4 to the negative 0.1t plus 29. Because this exponent is negative, the larger numbers going in for t are going to make this so small that this is going to go to 0. This whole thing's going to go to 0 as t goes to infinity. So this whole thing will go to a 0. Then I have 0 times 200 is 0. So all that's left is going to be 29. So as t goes to infinity, then this is actually going to just to the 29, whatever number is on the outside. I hope that helps.